Good morning.
Morning.
Wow, I feel like a comedian in a Vegas show with all the lights. I'm really happy to be here. Thank you for attending and being at S4. We'll be talking about something that we've been working on for quite some time. It's the first time that we are publicly speaking about it, so pretty excited to be here and share it with you all. NVIDIA is the world leader in accelerated computing. We are fundamentally changing how computing works and what computers can do. And I'm sure that everybody knows that we are the engine of the world's AI infrastructure. It's important to note that NVIDIA doesn't provide cybersecurity solutions directly. Instead, we offer a powerful computing platform designed for cybersecurity AI. And the idea here is that the platform enables our partners listed here to protect critical infrastructure through the power of accelerated computing and AI. And I really would like to thank the partners that are listed here. There are additional partners that are also working with us. You can see some of the integrations that these partners already did at the Armis, Ciolo, and Salvador Tech booths that are outside. And this is actually the way that we work. We build those platforms, and we have cybersecurity ISVs and manufacturer. We're giving them the ability to build their solutions, leveraging it. So I'm not going to talk about this slide. I'm sure that all of you have seen this slide many, many times. The question that we need to really ask ourselves is how can we adopt enterprise-grade security while preserving those unique operational characteristics of the networks you guys are responsible for, right? This is the big elephant in the room. And everyone that comes here and talks about a solution or a platform or a change needs to take it into account. Now, in my past, one of the roles I did was of a CISO. How many of you are CISOs? Raise your hand. None? Okay. How many of you are working in a CISO office or doing security roles at your organizations? Okay, more hands. It's a hard job, right? It's not simple. And for me, it was easier. Why? Because I could have just chosen whatever I want from the off-the-shelf security solutions, walk to the IT guys and basically say, OK, make it happen. And they would band whatever needed on the networking and the hosts that we had, and we would feel more secure. Here, it's a completely different setting, right? We cannot just do whatever we feel like and touch the network or make those changes, because that's not how those networks work. So how can we still adopt enterprise-grade security while still preserving those characteristics? What we will be showcasing here is our cybersecurity AI platform. What we're really doing is we are creating a security overlay, a virtual security overlay, that enables us to push security to every node at the network. This, at the same time, it will give us the ability to introduce those enterprise-grade security features because of the proximity of the solution to the nodes that we want to defend. And I'll explain that in the next slide or two. What this is going to enable is granular visibility and control per every system and any workload that operates on top of it. It will enable you to have the information you need in order to understand what's going on and how it is operating, while using AI in order to get insights about outliers and anomalies. The solution itself, which is composed out of two components, is invisible to attackers. The way it is attached to those nodes is tamper-proof. And it means that even when that host or the workloads and the workloads that are using it are under attack or have been compromised, it still provides with attested information about what's going on these machines. Now, you look at this, and you look at non-destructive operation, no agents, no performance impact, and you ask yourself, I'm sure most of you, I would say 99.9%, ask yourself, how is this magic even, possible? Because you know your networks better than anybody else. So what we're doing, we provide with a cybersecurity AI platform, which is really a full stack accelerated computing platform, And when we say full stack, we mean it provides everything from the underlying hardware and the system software to the acceleration libraries that are needed to power this platform. At the core of this platform, there are two key building blocks. One of them is the NVIDIA Bluefield DPU, and the other one is NVIDIA AI. So you must ask yourself, what is this NVIDIA DPU? So this is this guy, okay? It looks like a regular network interface card that you can put in any server you buy today from any manufacturer, because they all certified it. And really what this is a computer. This is, on the one hand, a network interface card, but on the other hand, this is a machine that has anything between 8 to 16 ARM cores, 16 to 32 gig of memory, and a full-blown Ubuntu OS operating on top of it. This guy goes into the systems that operates at level 2, 3, and the DMZ. It's part of the solution, not all of it, but it allows a lot of interesting use cases that we'll get in the latter of the presentation. The other part is our NVIDIA AI, which is, of course, powered by our industry-leading GPU acceleration, and by Morpheus, which is our cybersecurity AI software framework. Morpheus leverages the power of the GPUs in order to process petabytes of data in real time. And that allows it to handle everything from inferencing to training and all the way to provide with actionable insights. We're truly excited about this platform because of its flexibility and modularity. And as said, it gives the cybersecurity ISVs and manufacturers the ability to build solutions that leverages both the GPU and the DPU acceleration to secure critical infrastructure. So how this works together? The Bluefield DPU acts like a sensor. It's also an enforcement point that collects and streams traffic to NVIDIA AI. Then Morpheus uses that data as input and use it to apply AI models to profile behaviors, detect anomalies, and generate critical security insights in real time that are being pushed back to NVIDIA Bluefield for taking action if someone wishes to do so. So now that we had a quick overview, let's see how this platform can be applied to critical infrastructure in practice. In order to make the example easier, right, we're using an abstract of the Purdue model. And as said, we are positioning those Bluefield DPU cards to be replaced or to replace the network interface cards in the systems that are at level 2, 3, and the DMZ. Those cards have an out-of-band network interface that is connected directly to the card, to the ARM side. What I didn't say is that this card is completely isolated from the host. The host cannot breach it or tamper with its operation. We have actually created this card and it is installed by the millions in cloud service providers. So any name that you can think of wins. They all have it, they all are using it. We are also shipping this card, part of every AI node that NVIDIA provides. So this is something that is already proven and being used all around. What this card is doing is using this out-of-band network interface to literally create that virtual security overlay. Why virtual security overlay? Because the functions that now we're able to perform, and we are controlling not just the network, I'll showcase that in a second, allows us to send the information to the NVIDIA Morpheus Cybersecurity AI software framework and enable use cases not just that are related to security, but also that relates to operation. The Cybersecurity ISV, using this card, can provide, and we will show some examples, like the ones from Armis or the ones from Ciolo, that does network discovery, zero trust, a true zero trust secure access, provide with real-time threat detection, and more. And last but not least, but it's very important also to note, the information that one can glean out of the network discovery, for example, is crucial for other facets of your operation, where it can be used as input to digital twins that would now have the full information about how your networks looks like, what systems there are, and how they will be influenced if and when, so your simulations would look far more accurate rather than partial. Okay. We will now look at how this card operates and exactly what it can provide. We will describe the functionality, but then we'll talk about the use cases, and we will end up with showcasing some of the AI use cases as well. This card, as said, has two versions, anything between 8 to 16 ARM cores, anything between 16 to 32 gig of memory, a full-blown Ubuntu 2204 SSD, and what it means that literally you have a server on a card. That server also has acceleration capabilities for networking, storage, and security. Now, this card was designed for a whole different purpose altogether. Cloud providers, when they use virtualization, they use networking and security functionality that takes a lot of the CPU. And what we really did, we took infrastructure functions that are used in the cloud to segregate between different tenants, and we completely offloaded them from the host. So it means that they are implemented in and offloaded in this card. So they are running in a way that does not allow the host to interfere with their operation. If it sounds familiar, it also means that this is something that we can use in this case as well. As said, this card is isolated from the host. The host can't temper it, right? It can't access it as a whole. And a successful attack against the host or one of the workloads using it does not warrant the ability to alter policies that are applied to the infrastructure functions, and as those are enforced here and they cannot reach them. So even if even if the system is attacked, there's no way for the attacker to subvert those policies. If we want to translate this into more layman terms, then the hardware part here acts as a data plane, while the ARM and software parts acts as a control plane. Translating this to security speak, the hardware part is an enforcement point, the software part is a decision point. So how they play together and why is it so important for me to explain this and take some precious time talking about it? It's because how they play together. It looks complicated, but it's really pretty straightforward. When any system tries to communicate, so it might be any workload, it might be a virtual machine, it might be a container, it might be the system itself, tries to communicate with the outer world, or the outer world tries to communicate with it, a new connection is going to hit the hardware portion. The hardware portion has what we term as an embedded switch. Embedded switch, as its names apply, its role is to send the traffic to the right workload or the right virtual machine, and basically allow routing as well. Similar to if you're familiar with the concepts of virtual switching in software or in virtualization. So it employs flow tables that basically tells the hardware how to handle this packet, right? If there is no match found, the hardware is going to ask the software, hey, what should I do with this? I have no idea. And the software will apply the policy that was pushed to it to this new connection. If the new connection is allowed, what it would do, it will populate the flow tables and will allow the connection to operate. What this really allows us is to implement a few really interesting use cases. Now, we've implemented all this functionality in a software package, OVS Doka. Doka is the software development kit we're using, part of the Bluefield DPUs, to allow someone to rapidly develop solutions on top of it. So what is this allowing us? It allows someone, a third party, to take their next-gen firewall and implement it inside the card. This is something that was already done by some of our partners. And the next-gen firewall, with all of its capabilities, if someone wishes to operate it in a bump-on-a-wire way on the card that is attached to that system at level 2, 3, and the DMZ, can do so. One of the interesting use cases for a next-gen firewall is the virtual patching, as you know, or the ability to look at encrypted traffic when it is used, ability to have a built-in IPS, etc. So this is one of the use cases that we can do. The other one, which for me is even more interesting, is the ability to look at the traffic and decode it. As you'll see in the next slide, we don't just need to be bump on a wire. We can actually just get a copy of the traffic and operate completely as out of band. But in this case, the reason why we're still showing this as an out of band connection is that once you decode the protocols, you can actually look at the commands that are being issued to devices, and you can actually decide to act as an authorization layer and decide what commands are allowed per device type and what commands are not allowed. There is also a very exciting use case when you just want to audit the commands that are being issued to devices, where you can send those commands per the device type that are being issued to AI. The AI would profile the information and would yield the outliers that would mean which of your devices per that device type are being configured differently compared to the rest of the estate that you have. Just think about how hard it is to do today. The last use case that I want to show that relates to this is about how you can use this capability in order to perform network discovery, one of the biggest problems that we deal with here. And the way to do so is, on the one hand, to just passively discover whatever is happening on or for this device by listening to the traffic, decoding the protocols. A lot of solutions that are listening at the network level today have this capability. And like that, we can implement the same technology, but now at the host level, which means you get a far more granular information about everything that happens on the network. And the other kicker that you have is that we also allow to configure an active interface that is completely controlled by the ARM side and that Ubuntu side, and not by the host, and does not go through the host on the operational network if someone wants to also do active network discovery using the protocols that are used on that network. So here you have the ability to combine between passive and active network discovery and understand in full what goes on the network, giving you some important benefits and much more granular information about how all those things operate and what operates around the system that you're installed on. So instead of doing active network discovery by putting something on the machine that for a lot of you is a definitely no-no. You can use the card and you can do it by itself. So these are the networking part of what this card can do. But there's a hidden kicker here that is very unique to what we're doing. We have developed a way to perform live memory forensics. This card also does that. What this means is that since this device is a PCI device, it enables us to have direct memory access. And that direct memory access is hardware to hardware. It's non-tempered as well, or I should say attested. And what we do, we analyze specific snippets of memory that we access directly, and we translate those into logical information. So by looking at kernel structures, which are very small, we seriously don't care how big the memory of that system is, we are able to start painting the picture of the relationships between processes that operate on the machine, which we, of course, list them all, to what they are actually doing. The files they access, the network connections they open, the libraries and modules they load, threads they have, etc., which in turn also allows us to understand information about the system itself. This is unique not only because it operates from a DPU. This is unique because it allows us to use this information in order to provide not only with real-time visibility, but it also allows us to use this information in order to detect breaches in real time. So to the use cases. You'll see an announcement coming from Armis later today about their integration with the NVIDIA Cybersecurity AI platform. What they did is they took the technology they have from the passive network discovery they do at the network level, implemented it inside the card, added threat intelligence, and are using AI to find more information and glean more information about what is happening on the network. They can give you more information at the booth. I want to go over quickly over a use case that I think is transformative. Yes, there are so many use cases that I showed you that are possible, and some of them require more work, and some of them require less work. But if we ask ourselves, what is the number one attack vector that a lot of these networks suffer from, is the fact that IT is connected to OT, and a lot of the recent attacks in the last few years were the result of something trickling from IT to OT and our inability to actually segregate between the systems that we have. So how is this different? When you have a remote technician that tries to access the system, usually the solutions today only have a gateway that would authenticate that user, will record the session, and will then apply whatever policy. But the problem would be that in that case, there's a lot of cases where that remote technician, when access is granted to that system, might be able to laterally move across your network. Here, we are adding another enforcement point to the mix. The card, which is installed on those systems, is another enforcement point. So what happens is, when a new connection request comes in, the gateway now gets information from both ends of the equation. It gets information about that remote technician, how he was authenticated, the health of its system, the criticality of the system it wants to access, but it also gets information from Bluefield DPU about the system it wants to access. And that allows that gateway to really assess risk versus trust. So if you think about zero trust, what it needs to do, it needs to look at both of the sides of the equation. I wish I had the swing here that Dale used, right? I wouldn't try to work on it, promise. And what it does, it has all the information it needs in order to make access decisions that really takes into account both sides of the equation. So when access is granted, this guy actually pushes an ACL to Bluefield that prevents that remote technician from laterally moving throughout the environment and limits, according to that evaluation, what this remote technician can do, knowing what is the type of access he was requesting. So instead of granting full access, it can say no SSH, but some sort of a web interface, and so on. But the interesting thing here is that this is not done. We can actually look at the session, and while it is happening, we can apply AI to the video recording that usually these solutions use. So by streaming the video to AI image recognition, you can now understand what this remote technician is doing. And you can use that in order to look at any violation whatsoever that remote user is doing. Not only that, but if is there a material change that's happening on the system side, then the Bluefield card will tell you, hey, something has changed in the way those processes operate, or the way that the system operates in another way will raise a red flag, and that would allow the gateway to cut the code in session. How many of you collect logs and don't do anything with them? All of you. Okay, I will answer. I went to a substation back at my home country, and I asked the guy responsible for security, what happens when the red bulb goes on? He showed me the technician that is responsible for that. He's not IT. We need something that will allow us to cut the code immediately, and we need to safeguard our networks immediately as this happens. So this is a great way to actually do that. But when we looked at that, we said, wait a minute, we have an IT to OT problem as well. What if all those cards, and by the way, that card is configured to deny access to anything, which I forgot to say. So all those cards are configured to deny access other than to the systems that they are communicating with in the OT side. So anyone trying to come from IT to OT is denied. They can't touch it, and they are basically, the card is configured to deny all access, and it will report them. But it forces them to go through a similar gateway, of course, a different instantiation of that gateway, and that will basically allow you to do the same trick when you segregate between IT to OT. One guy not allowed to access is not going to be connected. The other guy, the same way. We will weight both ends, and we will see if it can access and what level of access it needs to have, limiting where it can go, what it can reach, and also being able to cut the code mid-flight if needed. Last but and not least is some cool AI use cases. This card, as said, allows us to send the telemetry to AI. It has a 1 gig out-of-band interface here, and we can send that information to AI and do some really cool things. So I explain about the commands. Think about your telemetry that's coming from the devices that you will also see on this guy, because it sees all the traffic coming in and going out from the machine it is installed on at those level 2, 3, and DMZ. So you feed AI with the information about the telemetry received from those devices per device. And what are you getting? Again, you get the outliers that are not operating as they should, and you can understand that something is going to happen with them, or that they have been configured in a wrongful manner, and now they are doing something they shouldn't have been doing in the first place. You can route the TCP/IP traffic if you wish to, and that will also identify outliers in the way the system operates. You can take the process to network communication, which is something that the Docker AppShield host introspection does, and look at that and basically baseline the behavior of your processes per the device stack and identify outliers as well. These are really exciting use cases because today they are nearly impossible to do. They're nearly impossible to do. Why? Because we're missing the sensor that will create the data that would feed the AI system that is there to help you run your security far better. The Bluefield DPU card in its placement and its ability to do all of those use cases I managed to squeeze into 30 minutes is able to provide you with that capability. Of course, powered by our partner ecosystem, that are working with us in order to better secure critical infrastructure. Thank you for your time. I'm here after the talk, happy to talk offline. Really excited to be here. Thank you guys for being here. Cheers, thank you.